everyone. Thank you for attending. This is Eray. I am with IBM Data Science and Elite team, and my expertise is all optimization. And today I'm going to be talking about a project that we have completed in Turkey last year, and it is about sales and operations planning. And today's agenda, I will first talk about the project. And this project has been already a success story for IBM. So I already presented this project before at some other webinars. So the slides that I will be showing firstly was mainly from the slides that I already presented some previous events. But in the second part of my presentation, I have some slides that I prepared just for this presentation. And in that part, I will more focus on the challenges that we have faced in the implementation project of ÇİMSA. So ÇİMSA is a cement manufacturer, and the headquarters is in Turkey, but they have global operations. There are manufacturing facilities, 5 of them are in Turkey, and there is now, with the acquisition last year, there are 2 facilities in Spain now. And they are in the white cement, ÇİMSA is the world leader. And whenever you look at, and this project is sales and operations planning is more about supply chain optimization. And whenever we talk about the supply chain optimization, strategical decisions have much more impact on the supply chain cost than the tactical and operational decisions. And here, when we talk about the sales and operations planning, it is, I would say it is something between strategical and tactical level, the decisions that we were trying to give. And with the ÇİMSA, IBM has different projects. So the project that I will be talking about today is the first one. Right now we already completed a second project, which is field mix optimization. And we are working on the third one. So in the sales, ÇİMSA S&OP team, what they are doing weekly is there's an executive meeting every week. And in that meeting, the ÇİMSA S&OP team, together with the executives and the CEO of the company also can attend to those meetings. And basically what they decide on is whether to sell or not to sell, like on the customer orders, how to assign a customer to which facility, and how to keep the inventory levels. At the end of every month, there's a kind of a safety stock that you need to keep. In some production lines, there are different production modes. Like you can switch between the high level, high, medium, and low speeds. In some kilns or in some production lines, I would say, you can convert the line. The line can either produce white or gray cement, and in a month you can decide on this. And there is also maintenance and balancing stops in the production. So you also need to decide on, okay, in this month or in the next one of the months, I'm gonna stop this line for this many days, and this is gonna be a maintenance stop, or maintenance stops are actually in our projects, they were fixed. But you are more deciding on the balancing stops, and the whole overall planning period is, in a typical S&OP meeting, it is the next 24 months, which is the next 2 years. So when as a solution approach, this is the overview of it, and like we collected the data and we built up a staging database, and we gathered all the data. The ÇİMSA is using SAP as an ERP, so we gathered all the data from SAP, or most of the data from SAP, and some are still being put manually or through spreadsheets. And then we feed our optimization engine through this staging database, and we also built up some custom dashboards for in this project. So if I get into more details of this modeling, from an input data, like, since it is a kind of whenever we talk about an S&OP, it is both in production, distribution, and warehousing. So we get data related to production, the bill of materials, different recipes, work centers, lines, capacities, and we get data on the transportation side and also the warehousing. We had constraints, and the constraints, especially from a optimization perspective, we really had to deal with a lot with the stopping of the lines. So there were some specific constraints on the setups or on the how to arrange the balancing stops on the lines. And the main goals on this model was both maximizing profit and maximizing the fulfillment. And at the time, like when we first started the project, there was no COVID. But now, after we implemented this project, we hit by the COVID. And what is happening now is in ÇİMSA, like they are all just like all the other companies, they are trying to do more with this. And there's a lot of scenario analysis that are being done through our application. And in the beginning, I said that ÇİMSA typically meets once a week to decide on these S&OP decisions. But now the meetings are much more frequent, and this application is being used much more than expected. And on the like, if I just summarize the business challenges just for the for this project, it's an integrated business, production and distribution problem. So there is one challenge on that side. You are not just trying to optimize production or not trying to optimize distribution. So you need to, from a business user or from an S&OP planner perspective, it is sometimes really complex to decide on integrated decisions. There are multiple objectives in this problem. The market conditions keep changing, and like before in the existing processes, it was a lot of manual processes. By the help of this project, ÇİMSA, there's a significant cost reduction that we expect, and there's now an automated system to run many what-if scenario analysis, and this is really something quite helpful for the ÇİMSA. And we kind of, such a project provided a visibility on the planning of the results. Beforehand, it was more a process that is being run through Excel spreadsheets, and there was that much visibility. But now all the stakeholders, all the executives can go through all the results of these optimization runs. And if I just talk more on the some technical details, as I said before, it is ÇİMSA was using SAP, and there's a staging database now. This is fully integrated. And this project, the whole applications that we developed from scratch. So everything was kind of a custom design and custom developed for ÇİMSA, including the interfaces. On the optimization model perspective, we first tried a lot of parameter tunings, and the model that we have is quite well tuned. On the other side, we really did some good job on the warm start, and it really helped on the performance of this problem. And this optimization, like on the ÇİMSA's problem, the optimization problem that we are talking about is like having millions of decision variables and constraints, because while we were trying to plan for the next 24 months, because of the stopping rules on the production lines, we had to get into the daily level as well. So the problem got really complicated. But from a challenge perspective, these are not really I think from an optimization modeling experts or for optimization developers, I again don't think these are some kind of a fun part of our job. But the challenges that I will be talking about will be a little bit different on this. So now this is the part that I really want to talk about today. So one of the challenges and the challenges that I'm going to be talking now is going to be just on the ÇİMSA case. So they are not the general challenges that I think on the optimization projects, but on the ÇİMSA, what were the challenges that we faced? One of them, as you would accept, the data is always a challenge. And typically, what will be the challenge on the data side is we all try to get a complete and clean data, right? And this is something really, I have been with the data science elite team since the last 1.5 years. And beforehand, I was holding optimization projects at IBM and some other companies as well. But with data science elite, I am more getting into some data science or machine learning projects, and optimization differentiates a lot on the data cleanness and completeness. So we really need a clean and complete data, which is all known. But on the ÇİMSA case, something that were different, not different, but a challenge was the data generation, because sometimes in optimization projects, we also need to generate data, in which what I mean here is like in ÇİMSA, ÇİMSA has some kind of existing processes, and they have been running this business since many times, and in some given way, like sometimes specific customers are assigned to specific production facilities, and it has been like this since the last 5 years, let's say. But whenever you try to do an optimization project, and then optimization is all about considering different alternatives, and alternatives can be on the transportation side. You can be looking at some different location assignments for these customers. So you need a transportation cost, which ÇİMSA didn't have, because they had always been sending the product from the same place, and they didn't have the alternative transportation cost. And it can be the case for the production as well. Like whenever you try to look for some different production alternatives, and if the client or if the company didn't have those production cost information in an optimization project, you might be also generating a data. And this is something really kind of a differentiator between other data science and machine learning projects, because I cannot even much think of doing a forecasting or running a machine learning algorithm with the data that you just generated. Like there is some oversamplings we do in these ML and AI projects, but this is really something different. And on ÇİMSA case, generating the transportation cost kind of from scratch, because there was no transportation cost before for some certain alternatives, it was a challenge for us. So this is one thing that I wanted to. And in my how I designed this deck is, I will first go through the challenges, and I have 4 main challenges, and then I will try to summarize the solutions that we had in our project. And the other challenge, and this is again, it was a challenge for ÇİMSA, but also I think this is a general one, the scope of the optimization projects. It is really hard to define the scope, and optimization is something really nice when you get into. So the clients, when firstly you decide on you agree on a scope, and you try to be as specific as possible, and all the stakeholders and all the parties kind of agree on kind of a statement of work. You have all your document of understanding things and everything, but through the project, I think there's always some more, like the clients can be asking for some more, or if your project's name is like in this project, the naming was end-to-end sales and operations plan. So the scope is from, just because of the name, the scope can be understood as as if we will be kind of optimizing the whole supply chain with all the processes. So one example is, for example, the maintenance. Like if you are doing a production planning project, the client can be easily expect you to do also the maintenance planning. And maintenance planning sometimes is a different optimization problem, the maintenance scheduling, I would say. So the scope was also a challenge on this project. The other challenge, I think, again, this one is kind of a general one, and one of the challenges that we had in ÇİMSA. I think it is always there is a trust challenge in our projects, and the clients can question you on the optimality of the solutions. And to me, it is like a calculator. Whenever I run an optimization model and I get a solution, it is how as much as I trust on a calculator, I also trust on an optimization solver. So, but it is for the clients, it is not like that, and there will be always a question on the optimality, and you need to prove that this is really the best solution that you can have. So this was also one challenge on this project. And other than this, like the duration of these projects, like with ÇİMSA, we have 4 projects on table. We are now doing the 3rd one. In some of the projects, for example, the fuel mix project was much more specific, and we could be easily complete those projects in a short amount of time. But in some certain optimization projects, the duration can be a little bit high, and within that duration, you can have some unexpected events. And I think this is something again that is different from the other AI or machine learning projects, because in data science elite, our typical duration is 6 weeks on our engagements, and within 6 weeks we can really build up a good application, and it is more on the machine learning side. But if I am talking about an optimization project, I really never been, I think, part of an optimization project that has been completed in 6 weeks. Maybe just one I could remember. But again, like the majority of our projects take longer. And one sample is like 10 years ago, I was doing another SNOP project with ÇİMSA, and ÇİMSA is ÇİMSA and ÇİMSA are kind of a sister companies. They belong to the same holding in Turkey, and ÇİMSA produces some fabric for the tires. And when we were doing the ÇİMSA project, within that project we had the Arab Spring, and ÇİMSA had a production facility in Egypt, which was in the center of everything. So the facility had to shut down. And there had been a flood in Thailand within this project. So there had been a lot of unexpected events in ÇİMSA. And when we came to the ÇİMSA, again, the project duration is now we have the COVID, and we are getting some additional requests because of the COVID, and there are some unexpected things. So this is also like the duration of these projects can lead to you to meet with some unexpected events as well. So just to summarize on the solutions, we really didn't do much of AI and machine learning on data generation. Like the ones that we did was quite basic. But I believe that AI and machine learning can help optimization on this, like especially if you really need to generate or forecast some data, just like transportation cost, they might be helpful. On the scope, I think it needs to be really specific, and you need to decompose the problem. Here in ÇİMSA, we tried it, like we have 4 different projects, but even with that part, I am thinking that we should have been more specific on the scope, even like maybe some more phases. And the naming of the project also matters. Like it should be also a specific name. Like a project name shouldn't be a supply chain optimization. When you put such a name, the expectations will be much more than you kind of agreed on. And on the trust side, visualization makes really difference. Like if you see a solution on web, it is different. Reportings, if I'm talking about sales and operations planning, landed cost is a kind of a good example. And what if analysis, like if the clients are able to generate their own scenarios and run it, they can be able to compare and trust on the solutions. And on the duration, by nature, some projects are longer. So there is nothing much to do on the duration side, I believe. And just to my final slide on the wrap up. Yeah, even though we had challenges, and we really had many challenges in this project, at the end, this became a success story, and the team is happy on both sides. I mean, both IBM team, the client, and we also had a partner in this project. And I think the most important part on the success is the team. Like it is much more important than the tool or the approach that you take. But those are also quite important. But the team in this project was kind of a one team. Like there were client team, IBM team, and a business partner teams. But they really, whenever if you go to client side, you cannot differentiate who is from which company. So they always have delivered this project with one team. That was important. And the approaches that we were taking is also quite important. And in the optimization projects, I believe that you need solvers. Like I really worked a lot with the heuristics. It is also hybrid approaches helpful, and in our warm start, we also take advantage of some of those. But at the end, again, solvers are important and the tools that you are using. So that is all on my side, and I hope I'm on time.